There are times when we manufacture to achieve a grand vision. SpaceX wants to take us to Mars within 3 years. How do you design and manufacture to make that happen? To make anything happen that's novel, untried, new, and visionary.
Let's go do what we know we can do. There are less boundaries out there than we think they are.
The one big thing in the future of manufacturing is going to be the evolution of machines and intelligence in machines that now start telling us what products to make.
Closing that gap from ideas to reality, from bits to atoms.
I'm a great fan of Steve Jobs' wonderful phrase, if you want to know what the future is, invent the future.
SpaceX, one thing they do really, really well, is they basically don't take no for an answer. If there's something not on the shelf or quickly developed that they could use, they develop it themselves in-house.
As market forces shift, manufacturing assumes new roles.
You have to innovate, right, to be able to truly capture a market.
Xometry connects customers needing manufacturing with the best shops and suppliers to do the job.
In order to keep the whole demand side of the global economy going, we have to shrink the time to market, the time of exposure to customer, right? And that's the supplier's responsibility and the purchaser's responsibility. Our software reads, predicts, perceives, if you will, what inefficiencies in production are occurring. The whole point is like to take the guesswork out, and it modulates across the supply chain for greater success.
The weakest link is between design and fabrication. Ideas are plentiful, but taking a design and making it is what's hard.
Manufacturing can't exist by itself. It needs to be supported by design tools, by software systems that operate in an ecosystem around it. These often operate in silos and independently of each other because there's very little communication often.
A lot of that can be alleviated. If we can bring that information into a design tool, then those design tools can be more informed.
Among the most powerful tools are those delivering generative design.
With generative design, the designer starts with goals and constraints, and algorithms synthesize the geometry that solves for those goals and constraints. The algorithms are searching through the design space by reconciling multiple objectives that are often competing. And those solutions populate a space, and the designer is still in the driver's seat. That's where we're going, is trying to minimize the possibility that the designs that have been created can't be made. The computational power that we have available to throw at the problem of design allows us to explore more solutions than we've ever been able to before.
Computing power goes far beyond design tools.
The broadest and the transformational change that's happening in manufacturing today is it's increasingly digital, democratized, and distributed. We're able to put sensors throughout the factory floor to capture data in real time and integrate that with sophisticated modeling and simulation tools with the capability to deal with uncertainty. You can track every part and every process, and you can capture the errors before they propagate.
Which comes close to the full available power of artificial intelligence.
When people are trying to understand the likelihood of anything going on in a shop floor environment, that's where AI is going to come into play. Whatever you're trying to understand in your shop floor environment, there's going to be data collected. AI can be used in any subset of your operation, whether it's collecting data, reporting on it, or doing a predictive model around it. Having a data engineer and data scientist is going to be an integral part of your business in the future.
Can AI-powered machine tools change themselves on the fly to perform new tasks?
The idea is to get to the point where the system reconfigures itself dynamically based on the work that's coming in. Even up to the minute, the system will reconfigure and realign itself to meet those outcomes.
If the part is large enough that requires 2 robots, they can actually self-organize
replan themselves to actually service that machine and load that machine, and then of course then go retest themselves. The idea of the robot being part of, like, say, a team may not inherently be new, but how it actually responds dynamically as a true partner or team member is new.
Machines working together, aware of each other, aware of themselves.
The way we want to make this equipment work together is to allow them to become what we call self-aware or more intelligent, so that the devices themselves will start to collaborate together and the manufacturing processes dynamically.
What that means is the machines that they have capabilities that they are aware of. They know how to announce these capabilities to external agents if and when required, and they know how to connect and augment the capabilities of existing systems if they need to. In the near future, I think it is going to be more of the fact that computers are being fed with so much information that they know how to build fairly accurate models of the real world.
The real world of manufacturing includes an ever-expanding array of new materials, some with highly exotic properties, from macro to nanoscale.
There are a lot of advances that are happening in the materials, for example. Metamaterials, high entropy alloys, all kinds of new advances being made, which are still at the laboratory stage.
Engineered to have properties not found in nature, to bend light, block frequencies, change acoustics, even make things invisible. At Xerox's Palo Alto Research Center, scientists and technologists work side by side with sociologists, ethnologists, and anthropologists. The human factor is crucial, but will advances in automation make the role of humans unnecessary?
I don't think the role of humans is going to diminish by any means. In fact, I think that they are the ones who are going to build or augment the intelligence, augment artificial intelligence, and build something like collaborative intelligence.
One of the things that we're learning in our Industrial Internet Consortium testbeds is what the human component is, because we know it's changing, but we don't know what it looks like in 10 years from now, 20 years from now. The reality is people don't go away.
A few of them have had enormous impact as entrepreneurial pioneers.
When you look at people like Jeff Bezos in Amazon or Richard Branson with Virgin, they see a challenge and they can highly focus on that challenge. Manufacturing needs that big leadership to come from outside of our space potentially. Those type of entrepreneurial mindsets, I think, bridge a lot of the gaps we don't see coming down the manufacturing pipeline, as it raises interest from our manufacturing companies today and the leaders in those companies across the globe, quite honestly, that says, well, we can do that too. In fact, we know better how to do what they just did then.
We can best know the future by creating it through the lofty ambition of inspired leaders and through all our resources now converging in novel ways. Generative design, inspired by nature, augmented and virtual reality, enabling distance collaboration, artificial intelligence, reconfigurable manufacturing for optimum agility, hybrid technology, additive and subtractive in a single machine, metamaterials and high-entropy alloys, all materials and processes digitized, a digital thread throughout a product's life cycle. It's all in a future we can make, a future we will make.